Good questions. Always ask. All right. All right. So, lesson 4, we get to talk about a number line. And like, oh man, number lines. My wife has to do these at her work. She's an accountant. She does numbers every day. All right. So, number lines for lesson 4. But before we get to number lines, let's do a quick little review thing. Just to refresh our brains, you should know these by now. Which one's bigger? Which one's bigger? 4 is bigger. How do I indicate that?
The alligator.
Okay, the alligator thing. Which way does it go? Okay, so it eats the bigger number. Okay, it eats the bigger number.
Scary.
Okay. All right. Just to refresh our brains, it always eats the comparison symbol, the term for it. The comparison symbol eats the bigger number. All right. That is old stuff, but it shows up, and people still get them confused in algebra. I'm not saying that my algebra student does, but it does happen. Okay, so let's just remember, always eats the bigger number. Okay. On a number line, which my wife actually has to do at work, just with crazy numbers, because she works for a bank and they billions of dollars involved and all this stuff. They're doing crop insurance and yeah, billions of dollars on cows. So yeah, when you get you're doing cows are worth some serious thing. All right, so number line. Not one cow. When you have herds of them, they're worth a lot of money. And when you have multiple farmers with insurance plans, you're talking lots of money. It's a lot of hard work too. Not easy job. Not an easy job. Most. Yeah. Anyway, so I just wrote a number line down. Put that in your notebook. I went from -8 all the way up to 8, so that should be in your notebook.
Mr. Shepard, my notebook up here?
I didn't see one.
Okay.
Okay, so -8 to 8. Make sure that gets in your notebook. Okay, I'm going to use this in different colors so I don't have to do a number line several times. Well, actually, I'm going to leave my number line and I'm going to erase it. You're going to do several number lines in your notebook. All right, so don't forget, next Wednesday you'll have your first test, most likely, and I'll be collecting your notebook, so that needs to be in your notebook. If you don't have it, put it on a piece of paper, stick it in your notebook later. You should have it when you come to class. Moving on. All right, number line. How do we just start off with some basics? Because by the end of the year, you're going to be making these hard. Okay, so we'll start off with something simple. 3 plus 2. You know that, right? 3 plus 2 equals 5. Okay, but how do we indicate the pattern of growth on a number line? All right, so we're going to indicate that in a certain way. So it looks like this. We start from 0, and we will just dot it up vertically, and then we're going to go to the right to the number 3. Okay? And then we're going to add 2 to that. So we're making a physical representation of the answer. I missed it a little bit. All right, so that's all we're doing. Okay? 3 plus 2 equals 5. All right, so this made a physical representation of what we were doing. Now, let me erase this part.
How do you do that with subtraction?
I'll show you. That's next one. Good question. 5 minus 2, minus 2 equals 3. So let's do it with subtraction. Okay, 5 minus 2 equals 3. So we'll start off with 0, and we'll step ourselves up, go all the way to 5, and we're going to take 2 away. So we're going to go up again, and we're going to go backwards to the answer, which happens to be 3. Okay, so you're just following the path it would take. 0 to 5, and then back to the answer, which is 3. You're just doing the pattern. Okay? It would also apply on something that would be a negative number. 3 minus 5 equals negative 2. And you can prove it by going 2, 3, and then going back 5, and getting negative 2. You can prove it. All right? Now, how do we do negative numbers? The next question. How do we tackle negative numbers? So, for example, 376 minus 840. 376 minus 840. How do we handle this as a negative number? You should recognize that this is going to be a negative number. How do we do the work? Yes, sir.
You put 376 above 840.
No, but good thought. Okay, so your very first thing you would do, seeing this problem, is to recognize A, my answer is going to be a negative number. And I'm going to write it like a normal subtraction problem. I'm going to write 840 minus 376. But before I solve it, I'm just going to put a negative sign there to tell me, hey, I know this is going to be a negative number. And then I'm going to subtract this like I normally would, except for I always put you always put the bigger number on top. All right? So you just do 840 minus 376, which turns out to be
Negative 464.
negative 464. Very good. All right? So you solved it like a normal subtraction problem. And the only reason why I recommend putting that negative sign down right away is so you don't forget. All right? You don't want to forget that. It's a common thing to forget that negative sign. Especially since you are going to be subtracting like you always have. Write the negative sign down first, otherwise you get something wrong that you didn't need to get wrong. All right? In the real world, a difference between a negative and a positive is a huge deal. Because it's always involving money. And that's not good if you mess up the difference. You end up paying fines and fees and all kinds of crazy stuff. So you don't want to do that. All right. Now let's talk about sequences.
Ooh.
All right, so the next thing we're talking about are sequences. Sequences. There are two kinds of sequences. All right, so the first kind of sequence is arithmetic. So, arithmetic. All right, so let me give you a pretty easy sequence here. All right. What is this one? What's the sequence? I got the even whole numbers now. Right? Or I'm adding 2 every time. That's all I'm doing. Okay, what about this one? Oops, almost messed that up.
Odd.
Okay? Those are the odds. But I'm also adding 2 for my starting place, right? All right, so those are arithmetic sequences because each term is being changed by the exact same number. Okay, each term being changed by the same number, that's what we would call an arithmetic sequence. Now, a geometric sequence is a little bit different. So, geometric sequence has a slight change into it. Here is the sequence I'll start with. Okay? This is a trick question. This is not a geometric sequence. Trick question. Okay. Here is the sequence that's geometric. So we got to be careful on these. Let's see, let me write it down. Here's a geometric sequence. 1, 2, 4, 8, 16. What is happening in this one? 1, 2, 4, 8, 16.
You're doubling each one. So 1 times 2 is 2, 2 times 2 is 4.
Okay, so what I'm really doing, yes, but what I'm really doing is I'm also adding the previous number to the, so get 1, 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16, which is the same thing as saying times 2. That's a geometric sequence. I'm taking something from before and getting a new number. But I'm still following a pattern, but each one's a little bit different than the previous one. And these numbers skyrocket high fast, depending on the sequence. This one, this sequence I wrote down is not arithmetic, it is not geometric, it stands on its own. What is happening here? There's two ways we can look at this problem. There's two ways to look at this problem. I'll make it a little bit bigger so maybe you can see it. Okay, I added a few more. Anybody? Any guesses? Yes.
Adding odd numbers.
Okay, starting with what?
It's like 1 plus 3,
Okay.
4 plus 5.
Plus 3,
plus
plus
7.
5, plus 7, plus 9, plus 11, plus 13. Yes, there's one more way to. That's one solution. There's another solution to this problem, which is why it's not arithmetic or geometric. It's not arithmetic because these are changing, right? And it's also not geometric because the pattern doesn't follow from the previous one. So, what do you think?
Is it added?
Not adding anything. I'll tell you that right now. It's a tougher one. What you probably go aha when I tell you. Gotta tell you. Okay, these are perfect squares. All right. 1 squared is 1. 2 squared is 4. 4 squared, or sorry, 3 squared is 9. 4 squared is 16. 5 squared is 25. So the first one, second one, third one, fourth one, fifth one, sixth one, seventh one, they're all squares. Okay? Next one would be 8 squared, which is 64, and so on. 9 squared, 81, and just keep going up. Okay? So that's the other pattern you take. Alright, so that's perfect squares. Okay, so let me give you a sequence right now. I'll give you the rule of the sequence. I won't give you the sequence. Here's the rule. K equals 2 times n. Okay, let's find the first 4 terms in the sequence. So, first 4 terms. Okay, so the first one, we're going to do K equals 2 times 1, which is 2. So our very first term is 2. Our second term is K equals 2 times 2. 4. K equals 2 times 3 for the third term. 6. And obviously you should guess what the last one is. K equals 2 times 4. 8. So that's our sequence. We did the first 4 terms in the sequence. Okay? Does that make sense? Alright, so let me give you one more sequence. You tell me what the... Here's a sequence. I'll tell you in a second. 3, 2, 1, 0, -1. What are the next 3 terms? Following the sequence, what's the next 3? -2, -3, one more? Okay, very good. Okay, that was an easy one. Okay, following the pattern through, that's an arithmetic. We're just going down by 1 each time. All right, so let's take a look at another one. One more. You tell me the rule. What is happening here? which would be called, yeah, which is called, we're doubling, right? We're doubling these options. Okay, 1 plus 1, or 1 times 2, 2 times 2, so on. We're just doubling each previous term. 4 times 2. Next one would be 8 times 2. Okay, any questions on that? You good?
I don't think that K equals 2 first term.
Okay. Let me go back one more. So, you had a question on this one? Okay, very good. All right, so K equals 2n. N stands for the number of terms. So we did the first term. So 1, I plugged 1 in for n. What is 2 times 1?
2.
So that's our first term. Our second term, we plugged in 2. What's 2 times 2? 4. Our third term, for third, we use the number 3. What is 2 times 3?
6.
Okay. And our fourth term, we use number 4. What's 2 times 4? 8. Does that make sense?
Why do we need this change?
Okay, because I've asked you, what is the first term? So we plug in the number 1 for first and use it by the rule we're giving. We're given that rule. N stands for its place in the term. So if I said, what is the 15th term? You would say, oh, 2 times 15 is 30. That's all.
Okay.
Okay, so the N stands for the term place value we are in. So if I said, what is the 64th term? You would say, oh, 64 times 2, 128. That's all that is. And I just gave you an equation that stands for the rule.
Okay.
Does that make sense? Okay.